How did the first galaxies in the universe form? How do galaxies grow so large? For decades, astronomers have sought answers to this cosmic mystery. At the heart of it lies the spheroid, a dense, star-filled region found in both spiral and elliptical galaxies. These spheroids, home to the majority of stars in the universe, hold the key to understanding how galaxies evolve. In a groundbreaking study, researchers used the powerful Atacama Large Millimeter Array, or ALMA, to observe ancient starburst galaxies billions of light-years away. These galaxies, shrouded in dust, were challenging to study until now. By analyzing their light with innovative techniques, scientists discovered something remarkable. Most of these galaxies have triaxial shapes, indicating a turbulent history of collisions and mergers. Two galaxies collide. Gas, the raw material for stars, flows inward toward their centers. The result? Explosive bursts of star formation, trillions of new stars created at rates up to 100 times faster than in our Milky Way. These events, occurring between 8 and 12 billion years ago, rapidly formed the spheroids we see today. Researchers used advanced metrics like the Sérsic and Spergel indices to map how light and dark matter are distributed in these galaxies. Their findings reveal that after the gas is depleted, the chaotic system settles. The once energetic galaxy calms, leaving behind a spheroid of aging stars. These ancient spheroids are more than relics. They're a window into the early universe. Each discovery brings us closer to understanding how galaxies grew in those turbulent first billions of years, and how the universe itself has evolved since its beginning. The cosmos is vast, and its secrets are many. But step by step, we're unraveling the story of how galaxies, and perhaps life itself, came to be. The rest of the news is in the link below. Do not forget to follow and share. Information multiplies as it is shared.